Now this next one may scare you, but again, it's the exact same idea. All we're doing is substituting in what we know, and we know that y is equivalent. It is the exact same thing as r times the sine of theta. And we know that x is the exact same thing as r times the cosine of theta. So we substitute that in. Notice I moved that 1 over. And now, what do you do here? Well, our goal is to solve for r, just like we'll typically solve a Cartesian equation for y. In polar, we want to solve this for r. And you might be concerned and be like, well, how do I do that? Well, notice that we have two terms here on the left being subtracted, and both of those terms have an r in them, so we can factor that r out. And what are we left with? We're left with 4 times the sine of theta minus 2 times the cosine of theta. And that's still equal to negative 1. Our goal is to get r by itself, so divide by that entire ugly mess there. R equals negative 1. Well, that's weird looking. R equals negative 1 divided by that whole mess. 4 sine theta minus 2 cosine theta. That right there, absolutely correct. I think it looks a little bit better to write it like this. R equals 1 over 2 cosine theta minus 4 sine theta. Ask yourself, why are those two equivalent? Because they absolutely are.